Welcome back to the channel. I just realized I'm wearing the same shirt as I did in the previous episode. You might think this is pre-recorded, but it's not, and I'm going to prove it to you because I've got some suggestions on my previous video. Well, actually, I got like 3 comments, but one of them had suggestions. So my man, Zivaro, or whatever his name was, I'm sorry, dude, I forgot to copy it here. But as you can see, we have some mighty suggestions, and very likely we're going to do some of them. And I also added, I'm not sure if you notice, my own. Let's go. Naturally, we will start from the bottom. Where else? FPS. Why do we need the FPS? Well, if you take a look at the screen here, and if I buy a hamster, or maybe if I buy 2 hamsters, the screen is updating like every second, and that's not really smooth. Something we need to fix. How do we fix that? First, let me just stop that altogether. The problem is that the code updates every second, and we may want to increase that a bit. So I was thinking, what if I was to move this whole section into a tick function? So that tick function is going to execute on every frame that we want to refresh. I don't know how to say that. Let me just move this whole thing, and let's make a tick function, and let me put all of it here. And I think this is fine. If I place game.tick here, it should just work like before. Perfect. Now, how do we add the FPS? Great question. I don't know. Let's figure it out. So first, I want to store the FPS value statically so I can change it later. So let's do that. FPS, let's try like 5 FPS. Basically, we don't want to overwhelm the browser because this is not really for performance. We just want to make it look a bit more smoother. So FPS 5. All right, this 5 FPS means that we want to refresh the screen like 5 times a second. Currently, it's doing it like 1 time. So what do? We just divide this by 5, which is great, but it's not gonna do any good for us because increments are also going to happen 5 times, and that's not good. How do we fix that? Well, we also have to divide the increments by 5 to count for that value. I'm really not sure if this is going to work, but let me try. So here am I going to make 2 hamsters. Well, yeah, it sort of works. Okay, so I have 2 hamsters. It's updating 5 times a second, but as you can see, we have like a little bit of oopsie here. The number formatting is not great. We have some issues, and I think we can address it. Oh, and I think I made a mistake here because I'm dividing by 5 and want to use my game.fps. Oh, I also made the same mistake here. Yep, there you go. Let me just add to this whole thing my comments. This is very far from an optimal solution, all right? We should divide the final output and not the actual calculation. The actual calculation shouldn't be done as many times as the frames change, especially because we are querying the dataset every time. This is a really, really bad practice, but I mean, we don't really have so much time to make everything, so I think we can just leave it like that. This is just for demonstration purposes, but if you want to make it better, you should definitely store these values statically somewhere, so you don't have to query the document all the time, because we are querying it here like 5 times a second. Yeah, that's not really good. So what happens if I increase the FPS to something like maybe 25? It should look a bit smoother, but then again, this is not the best way to deal with this. Let's just make 3 hamsters. Yeah, look at that. Does it look better? By a lot. Does it work like it should? I think so. That this looks like 3 a second as it should. I think we can leave it like that. Let me just take a look at my list here. Where is my list? Here it is. We can tick off FPS. We got that covered. Coincidentally, one of the suggestions is number formatting. I didn't quite remember the function, but there is this thing that's called toFixed, and we can define the number of digits after the decimal point, as it says here. So let's go with 2. Yeah, I think it should be okay. And as you can see, it's already looking much better. Let's make our 3 hamsters. 1, 2, 3. Butter smooth. I don't fancy the 25 FPS, but it's alright. Next step. We are so quick with the things there. We already have like 2. Here comes the bad. We should start with the save system. So we did the bottom 2. We should do like the first 2. Okay, for that we are going to use the browser local storage. As the name says, it's a local storage for the browsers. It's a great thing to store something locally. I think we will just make another timer function and say every 10 seconds we're going to save the game state. And when the browser refreshes, we check if this thing exists in the local storage and restore the data. Let's get to it. We made this a little bit harder to ourselves because it would be just much simpler to have every information of the game in one sub-property in one object, and we could just store that object and restore it back. But yeah, we didn't do it, but luckily we only have one to store the value and the buildings, because that's what we care about. Let me just make another function, save, and another one, load, and the save function, we do local storage set item, yes. Just code save, make a new object, and we just, as the game val, also the buildings, the game. Is this right? Yeah, I think this is all right. Also, we need to stringify this one because this doesn't gonna work. Stringify this object. What it does, this is gonna make it a string, and we're just gonna store it in the local storage. And what do we do in the load? We just wanna get back. Local storage get item save. I don't know what happens. There's nothing in the local storage, but let me check if I want to get back in. It's a null. All right. If save doesn't equal no, then let's just game dot val save dot val game save dot buildings. One issue we can run into if we expand the buildings and the save doesn't contain the new buildings, then we are gonna just make a mess. It would be just much better to loop over these buildings and basically do a merge, but yeah, let's just not do that. We are not gonna update this, or will we? Oh, I'll just figure it out later. Who cares? So we have a load, we have a save. Now we need to just save it. These functions are not invoked anywhere, so we do the init timer. I think we can put this here, so we do another set interval function, whatever. Let's do 5 seconds and do the game. Let's save. Will it work? Well, it should probably show a message of some sort. Let's just log into the console log, saving, loading, and the load should run before everything. Now, goodbye. Did I save? Yeah, I did save. What's the problem? Cannot read properties undefined hamster. Oh, no. What? Okay, tell us. Oh, wow. It goes to the line. Okay, what's happening? Oh, well, major issue. We forgot that we need to convert back the JSON string to an object. Whenever this is not null, then save is JSON bars save. Yeah, because that's what? Oh my god, why is it running 500 million times? It's because of the FPS. Let me just log this like this thing. Why isn't there nothing? What? Okay, now it looks okay. Saving. Let me refresh. Okay, saving. Yeah, it's working fine. I think what happened is that the local storage already had these objects stored, and I wasn't parsing and I wasn't saving and I wasn't refreshing, but now it should be okay. Let's check out save system. Alrighty, we don't really have an actual save button, but who cares? It does automatically every 5 seconds, and we don't care about 5 seconds of progress at the moment. So we actually have a save system. If you want, you can just add another button to like somewhere here, save, and it's gonna save. It's all right. Now, what's the next step? Where are we? Next step. Base idle calculation on time since last tick. Allow switching, minimizing tabs. So in other words, this is latency. And why this exists is because when you switch to another browser tab, this doesn't get focused. And sometimes the browsers doesn't allocate that much CPU to this background task. So we need to account for this latency. How do we do that? This is not very simple, but not too difficult. First off, we need our game tick, and in our game tick, we're going to calculate the latency basically. So we add the new variable latency, which is gonna be 0 by default. And also we need to store the previous runtime. This is gonna be a timestamp, so to say, where we basically store the previous tick's start time, and we check with the current tick's start time. And if the difference is larger than time it should take, then that means that we lost a bit of time. So we should like compensate for that. So we add together these latencies, and whenever this latency grows bigger than 1 time for a tick, we do an extra tick. Let's do that. So when this tick runs for the first time, then the game dot previous runtime is 0. So we should make it not 0. So if it's 0, then new date get time. Yeah, this is milliseconds. Yeah, that's perfect. And otherwise game previous runtime. All right, it's all right. Now at this point we have the previous runtime. If it wasn't set, now it's basically the now time, so it's all right. And in the next line, we should compare this to the current time. Game dot previous runtime minus 1 tick, which is 1000 divided by game dot FPS. No, I mean we need to add it together. All right. Yes. So whenever this is smaller than the current time, probably I should make the variable for it current time. And if this is smaller than the current time, should it be smaller than the current time? We add together, yeah, smaller and equals a bit smaller. Then we add some game dot latency. What if I were to make another variable? So this is so ugly. Difference is this, and if the difference smaller, basically this isn't the difference. What is this? This is the expected time is smaller than the current time, then it means we lost time. So we need to add it to the latency variable, which is the current time minus the expected time. Is this good? Or am I stupid? The expected time is previous runtime plus this, but the current time is bigger. Yeah, so we add the difference. All right. For now, let's just not do anything. Let me just log this. Game.latency. Well, 25 times a second. What if I were to place this one into? I mean, who cares? It's just fine. Yeah, that's definitely not okay. Am I doing something wrong? It's like too much. That's too many milliseconds. That's not possible. Let me think.
1 hour later.
I think I figured it out. I forgot to set the previous runtime. After all this deal, we also have to set the previous runtime to the current time, because it will not change. And now I'm seeing like maybe a bit more consistent values, but I'm not really sure. I'm really not sure if this is okay. Give me 1 more second.
Look at me, I'm thinking so hard. Did I forget to turn on the oven? Oh
All right, this turns out to be correct. When I change the game FPS back to 1, this number is not really growing too much. And the execution time is between 0, 1 to like 7 milliseconds, which I think it's correct. But when I increase the FPS, this one gets out of the hand really quickly. I think it is correct, so let's like roll with it. What we want to do next is like check if this latency is getting bigger or equals to the time it takes for one tick to execute, which is 1000 divided by the game.fps, and I think I'd rather use parentheses here. All right. So what do we do now? We have to invoke a new game tick, and also we have to reset the latency. We have already compensated for that one missing tick. It's gonna be 0. Okay, we have call stack size. We don't care about that. Another issue. This is gonna call itself all of the time because this latency, whenever it's bigger, this one is always calling itself. What we can do is like move this whole thing outside of the tick scope and whatever, or we just add an argument like do not check latency. If not, do not check latency. We do a latency check up to this point. Why didn't it end in my code? So this, which means we do not check for latency in this extra latency step, which should resolve the problem. There it is. How do we know if this is working? Console log here. Let's just log the latency here. What was the latency? Yeah, that's not working. That's really not working. Oh, mama. So how do I fix this? Well, maybe it's working because we are rolling 25 FPS, and that's a lot, and that's a lot, and it should take 40 milliseconds, and it takes like a bit more, and we should count for that. Yeah, I think it's working all right. It's actually working all right. Well, I think you will have to tell me in the comments below. By the way, if you haven't liked the video, make sure to like it, and if you haven't subscribed, then make sure to subscribe because, well, it helps me a lot. Okay, we can tick this out. We can check. We can say this is done. Is it done? Base idle calculation on the same time the last tick. Offline progress. Well, that's another issue. Maybe we can use this game.previous runtime variable to our advantage and check it against the current time and catch up during the load process. We already have a load function. What if we also stored the previous runtime? Yeah, I think we solved it. In my save, I'm going to save the previous runtime game previous runtime. So yeah, so we restore it, and we should like maybe do the catch up here. The game that previous runtime is not 0. Let's just check. Difference is the current time minus game that previous runtime. Difference is greater than 0. We could check how many ticks we missed. Ticks missed is gonna be the difference divided by 1000 divided by the game FPS. That's what it takes to execute one tick, and here we have the time difference. Well, I think that's the number there, but I'm not convinced. We missed 65 ticks. Let this run for a couple of seconds. So it saves, save again, and we missed like 37 ticks. What? All right, I need to close the browser. Let me close. Open again. 222. What's that? Is that like 40 ticks in 1 second? No, 25. What's it? Almost 10 seconds. Yeah, I think it's possible. From the previous save, which wasn't exactly at that moment, so I think this is actually working. Now, for the ticks missed, let E equals 0. E smaller than ticks missed. I think this is a very terrible idea because in our tick function we do DOM operations, and let's just try. Okay, so we have like 490 about energy, and I'm just gonna close the browser, wait like 10 seconds, put it back, I think it's working. I think it's actually working. Let me do this again. It was like, what, 5,000? Let me close. It's working. See? We didn't even have to do that much. I mean, it's all done. It's all done. Finally. Well, this game didn't get much nicer. It doesn't look nicer. This looks like crap. But at least now we have some bit more functionality and we can like expand it a bit more. I'm not sure if I will, but thank you very much for watching this video. Leave a like and subscribe, and please, in the comment section below, just tell me if you want me to continue this project or if you want to see something else. I'm almost sure I'm never going to prepare for any video, so you can see how this turns out in terms of real life. Thank you again and have fun. And by the way, one of you have asked if I will make a Discord server. Yes, I did, and you can find it in the description below. And I think I also add this small code into a GitHub repository. You can also find that in the video description below. And yeah, thanks for watching again. Bye.